Hi, this is Rob Yates, and this is the video for classwork number 4, which, as you may know, is page 29 and 30, numbers 63, and then 66 through 68. (63A) gives us several different types of functions. There's an input. In this case, it's the button that you press and a type of candy. Button number 1 gives you sticks. They press 1 again, likewise. Now, we have to examine these tables and graphs with their inputs and their outputs and decide if it is a function. So, here's my input, the button number. Here is my output, the type of candy. Is it a function? Does it have a unique output for every input? Let me direct your attention to what happens when I press 2. Here I get a mysterious candy called M&M's, and over here when I press 2 I get duds. What does that mean? If it means it's not a function, that's what you need to list here. Not a function. B also has inputs and outputs. Write these down on your paper. All right, as we look at our inputs, again, inputs, do we have unique outputs for each and every input? Up here we had 2, gave us 2 different things. 7 gives us 6, -2 gives us -3, 0 gives us 4, 4 gives us 2, 9 gives us 10, -3 gives us -3, 6 gives us 0. In no instance do we get anything but a unique output for unique input, so as far as we can tell, from what the information they've given us, this is a function. Let's take a look at C. C also has inputs and outputs. Now, as we look at our inputs and their outputs, do we have one output for every input? If I look at 2, I think you know the answer to that. This 2 gives me a 9, this 2 gives me a -8. What does that mean? Does that mean it's a function? Fill in your answer for, this is actually 3, Roman numeral 3. This is actually Roman numeral 2, Roman numeral 1. Apologize for the confusion. Let's go on to B. B asks us, a relationship between inputs and outputs is called a function if the inputs and outputs behave like a soda machine that is functioning properly. Discuss with your team what it means for a relationship between inputs and outputs to be a function. We can summarize something like this. For every input, there is only one output. C. C, we're going to use the vertical line test. And in C, we are given 4 graphs, which I don't have no ability to display for you. You're going to have to look at the book. And the 4 graphs are listed as IV, V, VI, and VII. If I look at IV, it is 6 dots that are placed on a coordinate grid. For every input, or X, there is only one Y, or output. So, if there's only one output for every input, I think you know that that means C is a function. If I look at V, or number 5, it's basically a spiral shape, chamber of a nautilus, if you will. If you did a vertical line test, you would definitely hit the line in 2 places. For instance, if I placed a pencil or ruler on -2, I would hit the line at +2 and -2y. It has 2 outputs for an input, so I think you know what that means. VI is a table, which I can show you. X and the H of X here again, we have inputs, and over here we have outputs. As I look at each one of these, -8, 11, 4, 3, 11, -8, 6, 3, -8, 11. I do have a repeat. I have -8 repeats, but in both instances, my output is unique, or the same as it was for the first. So, if all my outputs are unique to the inputs, what does that make that? I think you know. Number 7, or VII, has a line that looks roughly something like this. This is X, this is Y. If we do the vertical line test, we can see that as we place our ruler and run it along there, that it only hits in one place. If it only hits in one place, I think you know what that means. In 64, it tells us, Jay, notice that the line graphed at the right is a function, and they show us a standard line. Hey, I think all lines are functions, she exclaimed. Support your claim with a diagram. Is she correct? For 64, she's right if we have a line that has a constant rate of change. So something that falls into y equals mx plus b. All lines with a constant rate of change growing bigger or smaller are functions. Actually, we weren't supposed to do 64. I apologize for that. You don't need to do it. 66 says if the g of x is the square root of x minus 7, find the g of 8, the g of 32, and the g of 80. So we would do something like this. The g of x is equal to 8 minus 7. We're plugging in our 8 here. Well, we know that 8 minus 7 is the square root of 1. 8 minus 7 is just 1. What is the square root of 1? If you said 1, you're correct. Write that down. That's the answer. The next one would be something like this. What is 32 minus 7? And then what is the square root of that number? I think you can figure it out. Finally, 80, you're going to have to break out the calculator because it's going to be a decimal point. 80 minus 7 is going to give you a decimal point in the neighborhood of 4 and change. Let's go to a new page to do 67.
Honey?
Number 67 says, solve the equation below and check each solution. A is 6 minus x minus 3 equals 10. We have to combine our like terms here. 6 minus 3 is 3 minus x equals 10. You can solve it from there, I'm sure. I'm going to let you do that. Subtract 3 and then divide by negative 1 to get rid of this negative sign, and you'll be in good shape. B says 100x plus 300 equals 200. Well, first step is to, of course, get rid of 300. And when I do that, I get 100x equals negative 100, which means I divide negative 100 by 100. What does x equal? C is going to be 1/3 x plus 4 equals x minus 2. Now there's several ways to solve this, and I'm just going to go ahead and multiply both sides by 3 to make this x a whole number, which is one of, as I mentioned, several ways to solve this. Times 3 times 3. 3 times 1/3 is 3 over 3x, or 1x. 3 times 4 is plus 12 equals 3x minus, I've just done this, and now I'm going to do this, 6. I'm going to add 6. and I get 1x plus 18 equals 3x. Subtract x, and I get 18 equals 2x. I divide it by 2. 18 divided by 2. D, which I think, because I'm getting crowded, I'm going to do in a different color here. D is 36 minus 2x equals negative x plus 2. So, let's say I subtract 36. I get negative 2x equals negative x minus 34. 2 minus 36 is negative 34. Then I'm going to add an x to each side. Negative 2 plus 1 is negative 1x equals negative 34. Divided by negative 1, x equals 34. We're now on 68. 68a, as well as B, C, D, says find the f of x. And in this case, x is negative 4 for each function. So A says the f of x equals the absolute value of x minus 3. I am going to just plug in my negative 4 in for x, and I get the f of x equals negative 4 minus 3. Now I have to treat the absolute value bars like parentheses and do what's inside here first. So negative 4 minus 3 is negative 7. What is the absolute value of negative 7? That's your answer right there. B says negative 5 times the absolute value of x, or in this case negative 4. Well, that's the same thing as 5 times 4, negative 5 times 4. What is negative 5 times 4? I know you can figure that out. I'll let you do that. C, we're getting a little crowded, so I'm going to switch up here, says, what is negative 4 plus 1? And of course the bars mean what is the absolute value of negative 4 plus 1. We have to do what's inside here first. Negative 4 plus 1 is negative 3. What is the absolute value of negative 3? Put that down there. You'll be a winner. And finally, D. D says the absolute value of negative 4 plus 3, plus 3 minus 6. Again, we have to do what's inside here first. Negative 4 plus 3, negative 1. Absolute value of negative 1 minus 6, 1 minus 6. What does that equal? Put that down, and you will have completed your work for classwork number 4. Remember, there are tutors available in the library before and after school to help you with your algebra. Also, you can talk to your teacher. Check with your teacher when they're available. There are other algebra teachers besides your algebra teacher. They don't mind if you come by and say hi. They like it, as a matter of fact. Come by and see us. Thanks, and we'll see you on the next one.